The last topic for systems of linear equations is solving systems that are 3 by 3, or where you have 3 unknowns. And we're going to use one of the techniques we learned to solve 2 by 2 systems to solve the 3 by 3. Here's the information slide. We're going to use elimination. Now, you can use substitution. It is very difficult to keep yourself straight. And invariably, when I'm marking the tests, I see that it all falls apart and it's really time consuming and it doesn't work out. So I'm going to strongly suggest you consider using elimination. Okay, so you're going to start with 3 equations. I'll call them A, B, and C every time. And they can have up to 3 variables. So you're going to take 2 equation combinations, right? So you're going to pick 2 of them and you're going to eliminate 1 variable. And then you're going to pick 2 different equations and eliminate the same variable. Don't eliminate x, then go and eliminate z. You have to eliminate the same variable twice. You're going to create 2 new equations, D and E, and this will look like 2 by 2 elimination. You'll continue on. Let's see how it actually looks. So here I'm going to call these equations A, B, and C. All right. And I'm going to look for 1 variable to eliminate. It doesn't matter which one you choose. When I look at these 3 equations, the one that really stands out to me as the easiest one to eliminate is y. It has the same coefficient 1. Equation B has a negative coefficient. I can use that twice. It'll be awesome. So the first thing I'm going to do is use equation A and B, and I'm going to add them together. X plus y plus z equals -2, and b is x minus y plus 2z equals -5. Because the y's are equal and opposite, I don't have to do any changing of any equations. So x plus x, be careful with your math. The y's are going to disappear, and I'm going to end up with 3z equals -7. So let's call this equation D and set it aside. I'm going to switch colors. And now I can either use A and C, or I could use B and C. And because B and C have those opposite y's, I'm going to be lazy and use B and C for my second elimination. X minus y plus 2z equals -5. 3x plus y plus z equals -12. 4x plus 3z equals -17. And I'm going to call this equation E. All right, now I'm going to take D and E and eliminate a variable. For me, I'm going to eliminate z because it's already got 3's. What I am going to do beforehand, and this is my personal preference, I don't like to use subtraction in elimination. I like to set it up so it'll be addition. I'm just going to find -e to get that 3z as a negative value. So just multiplying, equals 17, multiplying everything by -1 to change the signs. Now I'm going to go all the way over here, and I'm going to add D and E. 2x plus 3z equals -7. -4x minus 3z equals 17. 2 minus 4 is -2x. The z's are going to disappear, and I'm going to have +10, -7 plus 17, which means x is equal to -5. So I have found the value of 1 variable. I'm going to take that -5 and go back a level. So I'm going to insert it into either equation D or E to find z. I don't go all the way back to A, B, or C because there's still y and z missing there. I have to go backwards, follow my footsteps backwards, let's say. Okay, so I'm going to go back to black here. So I'm going to use equation D. 2 times the -5 I just found for x plus 3z equals -7. Okay, so -10 plus 3z equals -7, which means 3z equals 3 and z equals 1. I found another variable. So now I'm going to go backwards another level. And I'm going to choose, let's say, equation A. X is negative 5. Y, I don't know. Z is 1. Equals negative 2. So I have negative 4 plus y equals negative 2, which means y must be equal to 2. There it is. I am proposing that the answer to this question will be negative 5, 2, 1. So if x is negative 5, y is 2, and z is 1, this should work in all three equations. So I used A to find the last answer, so that's one I've already used, but I better check my answer in B as well as C. Check it in both. So I'm just going to write the numbers up here so I can easily see them. So for B, negative 5 minus 2 plus 2 times z is 2 equals negative 5. Is negative 5 equals negative 5? Yep. Check it in C. Is 3 times negative 5 plus 2 plus 1 equal to negative 12? Negative 15 plus 2 is negative 14. Sorry, negative 13 plus 1 is negative 12. Yep. So this answer has been verified. Here we go with example 2. So once again, I'm just going to give my equations a title first, a name. Then I'm going to decide which one I want to eliminate. So x is 4, 5, 2, 5, not so good. Y is 3 things. I'm going to go with the z, because A and B, I don't have to do anything for. Use B and C after that. That'll work just fine. So here we go. I'm going to start by adding equations A and B. 4x plus 2y plus z equals 24. 2x minus 3y, sorry, clean up that x, minus z equals 2. 6x minus y equals 26. Call that equation D, set it aside. Now I need to go back and use two different equations to eliminate z again. I'm going to pick, well, B and C, because they're already opposite, but instead of using B, I'm going to double that equation so that I have a negative 2 to match. So I'm just going to write down 2b right here, because that's what I'm going to use. So take 2x, make it 4x by doubling it. Minus 3y becomes minus 6y. Minus z becomes minus 2z. And 2 on the right side becomes 4. Remember to always do the math to the right side as well. And we're going to take C and write it down. 5x plus y plus 2z equals 21. That's a very beautiful equation. 9x minus 5y equals 25. So be it. We'll call that equation E. All right. Not super awesome. I don't think I'm going to use the 6 and the 9 in the x's. I think I'm going to eliminate with the y's. So what I'm going to do is I'm going to multiply equation D by negative 5. Why I'm doing that is that multiplying negative y by negative 5 will make positive 5y, and that will eliminate nicely with the negative 5y in equation E. Okay, so we're going to make negative 30x plus 5y equals 26 times negative 5, negative 130. All right, my next elimination, I'm going to try and squeeze in right here. Negative 5d and e. So the equation I just made, negative 30x plus 5y equals negative 130, and e is 9x minus 5y equals 25. It's looking grim right now, but I can promise you These usually turn out to have nice integers as the answers. All right, so negative 21x is going to equal negative 105. And if I divide negative 105 by negative 21, I'm going to find x is equal to 5. There we go. Found one of our answers. So we are going to go back a step. We're either going to put x equals 5 into E, or negative 5d, or even equation D if you want to. I'm just going to use E because it's right above me. 9 times the x we just found minus 5y equals 25. I just moved it up a bit because I realized green on green wasn't going to work for me. 45 minus 5y equals 25. If we move the 45 over to the right side, it's going to be negative 20, and negative 20 divided by negative 5 will give us y equals 4. We found another variable. Now I'm going to try and write this one a little higher. We're going to go back and pick A, B, or C to put x equal to 5 and y equal to 4 into. I'm going to choose B because it has little numbers. So 2 times 5 minus 3 times 4 minus my remaining variable z equals 2. 10 minus 12 minus z equals 2. Minus 2 minus z equals 2. Watch your signs. Minus z equals 4. So therefore z must be equal to negative 4. If you used B to find your final variable, you're going to use A and C to check your answer. So I'm going to write the point up here that I think it's going to be 5, 4 for the y, and you always write it x, y, z, alphabetical order, negative 4. So I'm going to check that in A. Is 4 times 5 plus 2 times 4 minus 4 equal to 24? So I'm just quickly doing a little bit of math. 20 plus 8 minus 4. And you can see that will work. Checking it in C. Is 5 times 5 plus 4 plus 2 times negative 4 equal to 21. So 25 plus 4 is 29 minus 8, is that equal to 21? I don't need the next step to see that it's true. So final answer, 5, 4, negative 4 is the solution to that system. Sometimes you get lucky and one of your equations only has 2 variables, like in this situation. B is already missing y, so I'm going to use A and C to eliminate y as well, and then I'll already be at the next step. I don't have to do 3 variable elimination, so that's nice. All right, so if I want to eliminate y from A and C, I see in A it's a negative y, in C it's a positive 5y, so I'm going to take equation A and multiply it by 5 to create equal and opposite coefficients in front of the y. 5x minus 5y plus 25z equals negative 85. Yuck. And then I'm going to add that to equation C. X plus 5y plus z equals 7. Here we go. 5x plus x is 6x. The y's are going to eliminate. Plus 26z equals negative 78. And I'm going to call this one D. So my next step is I can use equation B, oh my goodness, and equation D to eliminate a variable. I'm trying to think about it. You know what? I'm just going to go for it. I'm going to use D, and I'm going to create negative 26b. I'm going to multiply b by negative 26 in order to make the variable in front of z negative 26. And you could have chosen to eliminate the x's. I just am making this choice. We'll see if it's a good one. Okay. Let's build it right underneath this time. So negative 26b, if I take 5 times negative 26, it gives me negative 130x. Well, we know it's going to be minus 26z because that was our end goal. And if I do negative 3 times negative 26, that equals 78. So I can kind of see where this is going, but we're going to follow the math through. So I'm going to move a very clicky pencil here. All right, negative 124x. Z's are eliminated, equals 0. So x equals 0. There's one variable. Okay, I have to go back to a 2-variable equation to solve for another one. Well, my choices are negative 26b, or equation D, or plain old b. I'm just going to use plain old b, because it's the prettiest. 5 times 0 plus z equals negative 3. Therefore, z is equal to negative 3. Second variable. And now I'm going to go up to any of those 3 equations, or in either A or C, pardon me, to solve for y, and I'm going to use C, once again, because it's the prettiest. 0 plus 5y minus 3 equals 7, 5y equals 10, y equals 2. There's my last variable. So I'm checking whether the point 0 to negative 3 works in all these equations. Well, I kind of used B and C already, so I'm just going to check it in A. 0 minus 2 plus 5 times negative 3, is that equal to negative 17? Is negative 2 minus 15 equal to negative 17? Sure is. That's the correct point. So there's lots of places to make errors. Expect to get integers for your answers at this point, and if it's starting to get messy, really just go back and start again. Watch your signs. Watch when you're multiplying equations.